Alright, let's start with number 3. X squared minus 4x minus 5 equals 0. So we just want to use the quadratic formula to solve this quadratic equation. So the quadratic formula, just remind ourselves, remember in our heads, it's this guy right here. Okay. So all we need to know are A, B, and C. Fill in all the A's and B's and C's, and we'll be ready to go. So the solutions will be x equals negative b. Okay, so b is negative 4. So negative 4 would be positive 4. Plus or minus the square root of b squared. So b is negative 4, and we're going to square that. Make sure you square negative 4. Right, you're going to get negative 4 times negative 4. So this number here should always be positive because this number always gets squared for every quadratic formula problem you would do. 4 times a would just be 1. There's a 1 there. 4 times a times c is negative 5. Over 2 times a, and a is 1. And we're getting there. So we get 16 minus, or plus, because we've got a negative times a negative, so plus 20 over 2. We have x equals 4 plus or minus the square root of 36 over 2. That's 4 plus or minus 6 over 2. So that's 4 plus 6 and 4 minus 6. Two different answers. 4 plus 6, divide that by 2, and then do 4 minus 6 and divide that by 2. So this will be 10 divided by 2, so that'll be 5. This will be negative 2 divided by 2, so that'll be negative 1. So 5 and negative 1 are the solutions for number 3. Okay, so that's the basic idea. Once we have the quadratic formula, we just need to know how to use it, and that's how to use it. You just plug in A, B, and C. Okay, let's go with number 8. Just another quick example, something where A is not 1. Okay, and it's really important that our equation be set equal to 0, and that there not be another number over there. Okay, and that has been the case so far. So x equals negative b, that's negative 10, plus or minus the square root of b squared, that's negative 10 squared, minus 4 times a times c. That's all over 2 times 5. X equals a positive 10 plus or minus the square root of 100 minus, let's see, 20 times 24. That's 480. All over 10. X equals 10 plus or minus the square root of negative 380 over 10. So x equals, let's see, we need to simplify this sum, so we'll have first I, right? That's the square root of the negative part of it. That's what I is, square root of negative 1. Then we're going to break this 380 into 2 factors, one of which is a perfect square, and we could make that 4 times 95, all over 10. x equals 10 plus or minus, the square root of 4 is 2. So we have 2I times the square root of 95 over 10. Now notice this term here and this term here both have a factor of 2. So you can factor out that 2. Over 10, and now the numerator and denominator have a common factor of 2. So that'll be a 5. So x is equal to 5 plus or minus I times the square root of 95 over 5. And the difference between this one and the one we just did, number 3, is this is as simple as it can get. Before, at number 3, we were able to actually add and subtract this number to this one and get a couple of nice clean numbers, but this is the best looking this could ever hope to be. So we'll just leave it like that. Next, we will do number 13. Okay, so this is just a little bit more complexity added on to these problems. We will have to turn it into, move it around, rearrange it so that it's in standard form. (3w squared minus 12w) equals negative 12. So like I said in the previous problem, it's really important that this be equal to 0. So let's add 12 to both sides. And there you have it. So now we're ready to apply the quadratic formula. X is equal to negative b. B is negative 12. Plus or minus the square root of b squared minus 4ac. 4ac over 2a. We got positive 12 plus or minus the square root of 144 minus 12 times 12 is another 144. This is 12 and this is 12. All over 6. X equals 12 plus or minus, this is the square root of 0. This would just be 0 over 6. So there's nothing to add and subtract here. There's nothing to plus and minus. It's just a 0. So it has no effect. It has no change on the 12. So this is just 12 over 6. So that's just 2. Just a single answer. Okay, and if we think about the parabola that this would make, the solutions to this equation, where this is equal to 0, would be whatever value of w or x. I guess this should have been a w. But whatever value of the independent variable that you can put in to get 0, and 2 is the only one like that. So it'll be some kind of a parabola. It'll open up. It'll be a little bit narrow, and it will only touch in one spot at 2, then go back up, rather than crossing at 2 different places. Okay. Now we'll do number 21. Number 21. Plus 9n minus 3n squared equals 2 minus n. So we want to get it so that it is a times n squared plus b times n plus c. Set it up just like that. So let's maybe put everything on the left side and put it in order. So we got 3n squared. Okay, that's the only n squared term there is. But for the n, we got 9n here, and we'll add n to both sides to get it off of the right side. So this will be 10n. And then we have a 4 here as our constant, except we'll subtract 2 from both sides. So we'll be left with a positive 2 as a result. And all of that is equal to 0. And now we have something we could use the quadratic formula on. N equals negative b plus or minus the square root of b squared, that's 10 squared, minus 4 times a times c over 2a, and a is negative 3, and equals negative 10 plus or minus the square root of 100, plus, because we got a negative times a negative, 12 times 2, that's 24, over negative 6, and equals negative 10 plus or minus the square root of 124 over negative 6. Okay, so we're going to simplify this square root. Let's see what we can find out here. The calculator. See what kind of perfect squares go into 124. 4 is pretty plain to see, maybe 16. Let's see. Maybe, no. 124, maybe divided by 9, no. 16, 25 is not going to work. 36, maybe. No, so let's see, 124 divided by 4, 31, definitely, that's the only possibility, because 31's prime, it can't break down any other way. So we've got the square root of 4 times the square root of 31 over negative 6, and is equal to negative 10 plus or minus, this will be a 2, times the square root of 31 over negative 6. These two here, this term and this term, have a common factor of 2. So we can cancel out that common factor of 2. We get negative 5 plus or minus the square root of 31 over negative 3. And we could, if we want, and the most common thing to do is to say, well, this has a common factor, this has a, or let's factor out a negative 1, okay? So if we factor out a negative 1 in the numerator, this will become positive. And nothing really happens to this positive and negative, because one of them would become negative and the other one would become positive, and you still have a positive and a negative. So factor out a negative there, and now the negatives can cancel each other out. Those factors of negative 1 can cancel each other out. And we'll have 5 plus or minus the square root of 31 over 3. And there's number 21. And we have run out of room, so let's go up here. All right. Number 22. That's z squared plus 15z plus 24. That should look more like 15z plus 24 equals negative 32. So now, first things, let's get this, so it's, in standard form, z squared plus 15z, and then we'll add 32 to both sides. We'll get 56 equals 0. And now it wants us to solve it two different ways, by the quadratic formula and by factoring. Let's just go ahead and factor real quick here. So we have a z and a z. We need to multiply to make a positive and add to make a positive, so two positives. And what multiplies 56 and adds to 15? That'd be 9 and 6. No, not even close. Let's see. Times, I believe that's 8 times 7. That is 8 times 7. That's 56. So either z plus 8 equals 0, or z plus 7 equals 0. So z equals negative 8, z equals -7. Those are your two solutions. There you go. So when we use the quadratic formula, we had better wind up getting -8 and -7. So let's see what happens. So we're going to use the quadratic formula. Z equals -b, so -15, plus or minus the square root of b squared, that's 15 squared, minus 4 times a, which is 1 in this case, times c, which is 56, all over 2 times a, which is 1. Z equals -15 plus or minus the square root of 225 minus 4 times 56, that's 224, I'm surprised the calculator is staying on top here. There we go. 225 minus 224 over 2. Z equals -15 plus or minus the square root of 225 minus 224 is 1. So the square root of 1, which is 1, over 2. So this is two different answers. We'll take -15 and add 1 and divide that by 2. Then we'll take -15, subtract 1 and divide by 2. So -15 plus 1 is -14 divided by 2. That's -7. -15 minus 1 is -16, divided by 2 is -8. So whether we do it by factoring or by the quadratic formula, we get the same answers, which we would expect to see. Okay. So that was number 22. Now we'll do number 31. Okay, so it says find the discriminant and determine the number and types of solutions. So the discriminant is the thing that winds up being under the square root. Okay, and it's called a discriminant because it helps us discriminate between what kinds of solutions we're going to get. We could get, let's just think about the graph and the crossing the x-axis. We could get two solutions. That'll happen the most often. We could get no solutions. That'll happen sometimes. What did I say? I hope I said one solution. We can get one solution where it just touches at the vertex, or we could get no solutions where it doesn't touch the x-axis at all. Okay, so we'll get two real solutions, one real solution, and if there's no solutions, like if it never crosses the x-axis, what we'll get is two imaginary solutions. So how do we determine which of these scenarios we have? Well, let's just look at what's under the square root. That's going to be b squared, so that's -8 squared, minus 4 times a times c. Okay, so this is -8 times -8 is 64, minus 4 times 16, that's also 64. So the discriminant, the square root part, is going to be 0. So that's going to be you'll have -b plus or minus all of this over 2a. So how many solutions is that going to give? You'll remember we did a problem where we wound up getting a 0 here, and what happened was it just has no effect. You don't add or subtract anything. You're adding and you're subtracting 0. So all you wind up with is whatever -b over 2a is. So that's just a single solution. So one real solution. That is what that means. If you get a 0 in the square root, there's just nothing to add and subtract, so there's no way to get those two solutions. So just one real solution. Now let's try number 32. S squared plus 7s plus 11 equals 0. So just look at this discriminant. That's b squared, 7 squared, minus 4 times a times c. So that is 49, minus 44. That's the square root of 5. Okay, remember we're going to take this negative b plus or minus this over 2 times a. So we wouldn't necessarily have to do it if we were working this problem all the way out. We wouldn't have to take negative b and add the square root of 5 and then divide that by 2a, and then separately take negative b minus the square root of 5. That would just be really messy. But what we do know is that we could do that. We could add the square root of 5 and we could subtract the square root of 5, and that would give us 2 solutions, and they would be real because this is the square root of a positive number, so it would be 2 real solutions. Right? And number 33, eight p squared plus 8p plus 3. So it would be the square root of b squared, that's 8 squared, minus 4 times a times c, and we'll get 64 minus 12 times 8, 12 times 2, 96. And then we'll get the square root of 64 minus 96, which is negative 32. And so we remember that whatever's in the square root will be added and subtracted to negative b. That'll be all over 2a. So what are we going to get here? We're going to add and subtract to negative b, so that'll give us 2 solutions. What kind of solutions? 2 imaginary solutions, because we are taking the square root of a negative number. You could do imaginary, you could say complex if you want. But whatever you call them, you know that they are not real solutions because you're taking the square root of a negative number. Let's do one more. Number 70. It's about jumping a motorcycle. So here's a ramp, and here's a landing ramp, and this motorcycle is going to jump on this parabolic arch. Okay, this arc here would be in the shape of a parabola, a really wide parabola. And let's see, stunt motorcyclist makes a jump from one ramp that's 20 feet off the ground. The top of it is 20 feet off the ground. To another one that's 20 feet off the ground as well. So this one's also 20 feet off the ground. The jump between the ramps can be modeled by y equals, let's write that equation down, y equals negative 1 over 640 x squared plus 1/4 x plus 20, where x is the horizontal distance in feet, so x would be this distance here. So this distance could be 100 or 50 or 170 feet, and we would just plug that in for x. And what would that tell us? What would y be? Y is the height above the ground in feet. So let's see, x is horizontal distance. So I guess we know how fast he's going, we know what gravity is, and all the conditions taken into account. Whatever the distance is that he has traveled so far. If he's traveled this far, this far, this far, we can just plug that in for x, and that'll tell us how high he is above the ground. So there's the motorcycle's height. What's the motorcycle's height when it lands on the ramp? Well, when he lands on this ramp, he will be 20 feet off the ground, because that's how high the ramp is. What's the distance d traveled between the ramps? Okay. Let's see. Okay, so what's the distance between the ramps? That's what we want to find out. So we can find that out by saying that this equation, whenever this equation is equal to 20, then either he's over here at a distance of 0, or he'll be at this other distance. So we should expect to find two solutions to that equation. Let me write that down for you. Whenever this equation, whenever you put something in for x and you wind up getting 20, right? That x value that you put in must be either here at this ramp, or you could also, there's some distance that you could put in that's all the way on the other side that would also give you a height of 20. Because it's when he's on the ramps, whether he's taken off from this one or landing on this one, that he's at a height of 20. So when we solve this quadratic equation, you get negative 1 over 640 x squared plus 1/4 x. Then we subtract 20 from both sides, and what we get is 0 here and 0 there. Okay. And now we could, let's see, multiply by 640. Multiply by 640 just to cancel out those denominators. So 640 divided by 4, 160. So we get negative x squared, that 160, plus 160x equals 0. We can factor out an x. Negative x plus 160 equals 0. So either x equals 0, or negative x plus 160 equals 0, or x equals 160. So if we put in a value of 0 for x, we'll get 20. And that's no big surprise, because at 0 distance, he's coming off the ramp, so he'll be at 20 feet. And at 160, if we put 160 in for x, that means that this other distance way over there must be 160 from here to there. So 160 is the distance between the two ramps. Part C, what's the horizontal distance h the motorcycle has traveled when it reaches its maximum height? Well, we know that it's 20 feet here, 20 feet here. We know parabolas are symmetrical, so we know its maximum height is right in the middle, and so it must reach, the motorcycle must reach its maximum height at 80 feet. Okay, and so what is that maximum height? How high does the motorcycle get? Well, we can put in a distance and get the height, so we can just put 80 into this equation, and it will give us the height. So let's do that. Okay, we will say 80 squared. So 80 times 80. And we will divide that by 160. Not 160. 640. So 80 times 80 divided by 640. That's this part here. That's 10. So 10 plus 80 divided by 4. 80 divided by 4 is 20. So 10 plus, or let's see, that's negative 10 actually. This is negative 10. Negative 10 plus 20, well that's just a positive 10. plus 20, that's 30. 30 feet, that's how high the maximum height is. Okay. So there it is. We got the 20 feet right there by just understanding that when he lands on this other ramp, it's at 20 feet high, so that's how high he's going to be. This is 160 feet because we said, well, whenever this equation that we're given is equal to 20, then that means that we've put something in for x. It gives us 20, which means that at that x, at that distance, he's at a height of 20. So we found out that that was 0 and 160, which meant at the jumping off of the initial ramp, he's at 20 feet high. That's pretty clear. And then at the landing of the landing ramp, he's 20 feet high, which means that the landing ramp must be 160 feet away from the launch ramp. And then where is he at his maximum height? Well, that must be right in the middle. And right in the middle of 160 is 80. And then what is the maximum height? We just put 80 into the function and found that his maximum height was 30. All right, so that's it for 4.8. Thanks for watching.